Good morning, students. Welcome to Linear Algebra, semester 5th. I am your professor Dr. Virendra Palse, who will be taking in this class. Before moving to the main topic, which is vector space, let's first understand few preliminaries. The first one is binary operation. We all know from class 11th and 12th that what is our binary operations. Nevertheless, we are now defining it to revise all this. Take any non-empty set, then a mapping from its Cartesian product to itself. Yeah, in other words, we can say then if there exists a function from its Cartesian set to itself, then that function is said to be a binary operation. In other words, we can say, let's say O is a function is a mapping from V cross V to V, defined like this: O of V is V. Then function is said to be a binary operation. That mapping is said to be a binary operation. Another very important, which we have studied in class semester 4th. What's a field? Non-empty set together with two binary operations, addition and multiplication, is said to be a field if it satisfies few properties. In fact, it's 11 properties. First 5 properties under addition, then 5 properties under multiplication, and then one multiplication distributes over addition. The properties under addition are: the sum of two elements of the field again belongs to the field. This property is known as closure law. Second, we all know what is a commutative law. A plus B should be equal to B plus A or F. Third is the associative law. A plus B, its addition with C is the same as A plus the addition of B plus C. Then the existence of additive identity. There must exist one element in the field in the set F which satisfies this condition: A plus that element should be equal to A, or that element plus A should also be equal to A, and this should hold for every element of the field F. We generally denote it by 0. The element 0 is called the additive identity for the field F, but this 0 does not say ये जो मैथमेटिकल ज़ीरो है वो नहीं है, इट्स ओनली ए सिंबल, बिकॉज वी आर डीलिंग विद नंबर्स एंड नंबर्स में ज़ीरो को हम ऐड करेंगे किसी भी नंबर के साथ तो वही नंबर वापस आ जाता है. सो वी गिवन अ स्मॉल नोटिफिकेशन फॉर इट, इट्स लाइक ज़ीरो. देन द फिफ्थ प्रॉपर्टी विच वी स्टडी इन ग्रुप इज द एग्जिस्टेंस ऑफ एडिटिव इनवर्स. फॉर एवरी एलिमेंट ऑफ द फील्ड देयर मस्ट एग्जिस्ट अनदर एलिमेंट इन द फील्ड, अगेन इन द फील्ड. Remember this thing, such that A plus B should be equal to additive identity, or that should be equal to B plus A. Then the element B is said to be the inverse of the element A. Then we have 5 properties under multiplication. Again, first is the closure law. It should be closed under multiplication, which means if we multiply any two elements of the field, then the product is again in the field in that set. The second property under multiplication is the same commutative property, which means A dot B, multiplication is commutative, A dot B is equal to B dot A. Then the associative property, A dot B dot C is equal to A dot B dot C. Again, the existence of multiplicative identity. There must exist such element which, when multiplied with every element of the field, gives that element of the field. We generally denote it by 1. 1 belongs to F such that A dot 1 is equal to 1 dot A. Next, fifth property is existence of inverse. Every non-zero element of the field must possess its multiplicative inverse. एडिशन में नॉन ज़ीरो एलिमेंट की बात नहीं की थी, बट मल्टीप्लिकेशन में वी आर टॉकिंग कि एवरी नॉन ज़ीरो एलिमेंट must possess its multiplicative inverse. It means for every non-zero a of the element of the set F, there must exist an element B of the set F such that A dot B should be equal to B dot A, and it should be equal to the multiplicative identity of that set 1. Then the element B is called the multiplicative inverse of that non-zero element A. Next, 11th property is multiplication is distributive over addition. Multiplication distributes over addition. We have bifurcation 2, one left distributive law and the other is right distributive law. लेफ्ट साइड से मल्टीप्लाई करेंगे तो लेफ्ट डिस्ट्रीब्यूटिव ला है, राइट साइड से मल्टीप्लाई करेंगे तो राइट डिस्ट्रीब्यूटिव ला है. ए डॉट बी प्लस सी इज ए डॉट बी प्लस ए डॉट सी. इट्स वेरी सिंपल. Similarly ए प्लस बी डॉट सी इज ए डॉट सी प्लस बी डॉट सी. नाउ वी डिफाइन for defining vector spaces one external and internal binary operation. Internal means we are dealing with the elements of that set only, and external means we are defining one element from the other set. Let's take two sets V and F. Why we have taken V and F is V will be standing for vector spaces in the coming lectures and F stands for the field. Then the mapping F from V cross V to V is called internal binary operation, and a mapping G from F cross V to V is called external binary operation. Here the multiplication is internal within the elements of V, but here it is with the elements of the F. So it's external binary operation, and for the first case it's the internal binary operation. Now let's come to the main topic, which is very important. Throughout this chapter we will be studying only vector spaces, its properties. Let us define now vector space. Let V be a non-empty set and F be any field. Then V is said to be a vector space of the field F if the set V along with two operations, binary operations. Now here comes one internal and one external. Addition is the internal binary operation and scalar multiplication is the external binary operation. And if this set along with these two binary operations satisfy 10 properties, then we will say this vector space along with addition and scalar multiplication is a vector space. First properties under addition, it should be an abelian group under addition. All the properties of a abelian group: closure law, x plus y belongs to V for every x y in V. Associative law, x plus y plus z is x plus y plus z for every x y z in V. Commutative law, x plus y equal to y plus x, and we know that this property proves the abelian property. Existence of additive identity element: 0 belongs to V such that x plus 0 equal to x plus 0 plus x for every x in V. Existence of additive inverse: for all x in V there exists minus of x such that x plus minus of x is 0. Then the properties under scalar multiplication. And remember, it's not multiplication, it's scalar multiplication. We have to multiply it with a scalar because scalar comes from the field. First is the closure law: alpha into x belongs to V for every x in V, and alpha in the field. Similarly, alpha into x plus y is alpha x plus alpha y for every x y in V, and alpha in F. Alpha plus beta into x is alpha x plus beta x for every x y in V, and alpha beta in F. Alpha beta into x is alpha into beta x, and 1 dot x is equal to x dot 1. Thank you, students.